Okay, lesson 215, let's do this. How can I simplify the expression? Using algebra tiles to simplify algebraic expressions. We have started doing some simplifying, and hopefully class today made sense as far as how to simplify things. Please remember the 3 legal moves we talked about. One is to zero pair 2 different tiles in the same region. One is to take one from each top, the same identical ones from the top and the bottom, and the third one is to flip it, okay? So we're going to be using those today. Which is greater, 58 or 62? That question might seem easy because the numbers are ready to be compared. However, if you were asked which is greater, 2x plus 8 minus x minus 3, or 6 plus x plus 1, the answer is not so obvious. In this lesson, you and your teammates will investigate how to compare 2 algebraic expressions and decide whether one is greater. So that's what we're going to be focused on today, okay? Here's our first problem, problem 246. So on your paper, again, it should say 2.1.5, nice and big, and then problem 246. For each expression below, use an expression mat to build the expression, and then find a different way to represent the same expression using tiles. Now, what I have done is if you go to your stream, your classroom stream, there it is right there. Then if you look at the newest announcement that I put on the stream, and if I can go to it without writing, let's try this again. If you go to the newest, look right here, CPM tiles. Here's a link to the algebraic tiles expression mat. If you click on it, it just brings you to here, okay? So what I'd like you to do is, in just a second, I want you to try to bring that up. And I know this is going to be kind of weird. You can try the dual screen if you want to. Otherwise, you can pause my video and you can go to this and try to build it. But I want you to build our problem, and it is right here. 7x minus 3. So on your paper, please write 7x minus 3. 246a, 7x minus 3. Then you're going to pause the video. You are then going to build it. And then when you're done building it, I want you to unpause it and see if you match with mine. Got it? Go. Okay, hopefully you pause the video, and I'm going to walk through it here really quickly. 7x plus 3, or minus 3, so 7x, so 1, 2, 3, 4, 5, 6, and 7. Now it does say 7x minus 3, 7x minus 3. And so what I'm going to do, my choice is to put 3 down here. Now some of you argued that, Mr. Ramirez, isn't that the same as? You're right, that could work. So another way I could have shown this, and that's actually part 2. Look at this. Part 2 says, find a different way to represent the same expression using tiles. So the same expression. So another way, how's another way to write this or show this exact same thing a different way? Okay, now don't be lazy. If you didn't do this one, don't do this one. But try to find a second way to show it, okay? So can you? Unpause it, and then or pause it, and then try it, and I'm gonna build a couple others and see if you agree with it. Okay, so here's what I decided. So, as I said, some of you in class were like, Mr. Ramirez, isn't that the same as flipping it? Couldn't I have done this and put them up here and boom, 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 like that? Yeah, but technically what we have there is 7x plus negative 3. Or, guys, do you see the connection? Plus negative. Add the opposite. So 7x minus 3 is the same as 7x plus negative 3. So that is another way to show it. So you might have shown that. But then other than that, you're probably thinking, wait, what other way is there to show it? How else could I do it? I don't get it. Well, how could I build this set with, I don't know, more tiles? How could I add tiles and still keep the same value? Well, it kind of comes to what we did in class today. It's all about a zero pair. Couldn't I come up here and add a zero pair? Would that change my value? How much is this worth? This is worth 0. And if you add 0 to something, what does it do? Nothing. So I could add that, and that would take care of it. So you know what? I could add multiple sets. I could go here and go, woo, like that. I could also go here. Ooh, look at this. Could I do this? Well, whatever this value is, if this is the opposite, wouldn't they cancel? Wouldn't that be a zero pair as well? Yes, it would. So all of this is still the exact same value. So any of these combinations, you could add 0 pairs, and you can even go like this. You could say, oh, that doesn't work. Okay, don't do that. But you could say, hey, I'm going to add a y squared here and a y squared down here, because remember, these cancel out as well. This is a 0 pair as well, okay? So adding that, that's still the same value of 7x minus 3, okay? All right, so let's clear that out now. Let me get rid of this here, just a second, clear ink. And getting rid of the tiles here. What I want to do now is I want you to try the second one. Now the second one's a little bit tougher here, okay? So letter B. Oh, can you write that down first? B equals the opposite parentheses, negative 2x plus 6, close parentheses, plus 3x. Can anyone build that exactly how it's written there, okay? Not changing anything, not doing anything else, just writing down what's up there. Can you? All right, do it. Pause the video, build it, and when you're done, unpause it, and we'll compare. Okay, let's see what you came up with. So let's do it. Now, this, of course, is my problem for before, so I need to get rid of these here. I'm just going to move them down because I might reuse some of these. Okay? So, there it goes. I have the opposite of negative 2x plus 6. Negative 2x. The opposite. See that? The opposite of. Parentheses tells me everything in there is going to go just as shown. Negative 2x plus 6. So if it's plus 6 and it's inside the parentheses, I'm going to bring up 1, 2, 3, 4, 5, and 6. There is the opposite of negative 2x plus 6. But I'm not done, because it says plus 3x. Plus 3x. No, plus 3x. That is what I'm looking for. Is that what you come up with? If it is, good work. If not, again, some might be arguing, but Mr. Ramirez, I wrote it a different way. Well, but this is exactly what it says, okay? All right, so now your challenge is, can you write this a different way? Can you show the same value a different way? Well, let's go with, again, what Zach mentioned. Let's flip these tiles here. Oh, if I like that. I could go here. Oh, hold on. And I've moved these up, and I've got to flip them, don't I? Because they've got to change to their opposite. So that is the same. I could also add 0 pairs and say, hey, this one and this one. Or I could flip this one and have this and this. Okay? Any combination would work. Okay? I want you to feel comfortable knowing that you can add or take away tiles without changing the value as long as you're doing 0 pairs. Cool? All right, so that's that first problem. Let's go on to the next problem here in class today. Next problem. Please be careful here with this one. Comparing expressions. Problem 247. Two expressions can be represented at the same time using an expression comparison mat. This is different here, guys. The expression comparison mat puts two expression mats side by side, as you can see right here. So, okay. So you can compare them and see which one is greater. For example, in the picture at the right, the expression on the left represents negative 3, while the expression on the right represents negative 2, because it's positive, it's in the opposite region, right? Since negative 2 is greater, remember with negative numbers, the smaller they are, the bigger the numbers, the smaller the value. So 3 negatives is less than 2 negatives, so the expression on the right is greater. See it? Okay. So now we're going to try this out. Build the expression comparison mat at right or explore. So if you have your book open, if you are open to your book, you can just click on this tool right here and it'll come up with it, okay? In fact, I kind of want you to do that. I know it's a little annoying, but going to your book would build that really quickly for you. Otherwise, you can just build this on the expression comparison mat. You can't really, okay? So here's what I'm going to do. I'm going to cheat and I'm going to use it myself, okay? And then that might help you out. Okay, and the question is, can you simplify each of the expressions so that fewer tiles are used? So simplify, think of the ways we did it. Develop a method to simplify both sides of the expression mat, comparison mats. Why does it work? Be prepared to justify your method to the class. And then, which side do you think is greater? Okay, so I'm going to go here and I'm going to go to my book. I'm going to go to my book, which I've got over here. Hold on just a second. Sorry about this. Here's my book. It's just an easier way to do this. Okay. And I'm going to go down to the problem we've got, which is, oh, I'm not even in the same lesson. See, I didn't change that from the lesson today. So 215. And here it is. Okay, so I'm just going to click on this. And here's the expression comparison map. So here's what I want you to do. I want you to either build it and simplify it, or copy this down, like make a sketch of these and simplify it. You are then going to simplify, and you're going to tell me which side is greater, the left side or the right side. And what I'd like you to do is I'd like all of you to put a comment, a private comment on this assignment telling me which side you think is greater. Is it the left side or the right side? So I'll be looking for a private comment from all of you, either left or right, as to which one you think is greater. We will discuss this tomorrow. I'm not telling, but I do want you to have this simplified. I want you to tell me either by having it drawn or by writing out your final answer on your notes for today. Got it? That's the first thing we're going to discuss in class tomorrow. All right, that is it. We will finish up the video or the lesson tomorrow. Have a great day.